Today I'm going to talk about the 2024 hot mix asphalt specification changes. First off, before we get started, I wanted to point out the key. So at the very top, you'll see where it says item numbers that are affected by the change. Since there's so many changes, we really tried to be efficient. And so if the change only applies to, say, items 341, 344, and 346, that's where it would be listed. In the area right here in bold where it says section within the specification, this is going to point to the direct section within the spec, such as exempt production. If this were a discussion about exempt production, we would list that here. If there's just normal black language, that's language that currently exists within the specification and that will remain in the 2024 specification. The red portion here that has the strike through, this is language that's been removed from the specification. We put it there so that you can see where the changes occurred. And then the yellow highlighted portion will have any new language. And we have tried to highlight that just for easy reference so you can see what the new change is and possibly what the implication is. So if anytime during this presentation or during your plan review and you need to go back and look at this presentation, refer back to this navigation key if you're unsure what each of those stands for. So to get started, item 341, 344, 346, and 347, as noted in the top. You'll notice in the fine aggregates table, the first thing I'll point out is organic impurities has been added to this table. This is not a new addition. This is something that's been listed under the fine aggregates portion in the paragraph directly above this. Industry did ask in our conversations that we just add it to the table for quick reference. Do note that this is an optional test, so nothing has changed. We've simply just added it to the table to make it easy to reference. One change we did make, if you can see over here, there's a footnote 3 on sand equivalent. We've done this to add an optional methylene blue test. And so the reason we've done this, historically, we had the sand equivalent on the combined fine aggregate, and we didn't have as many materials failing. However, in the special specifications that we're currently under, we did change the specification such that we run the sand equivalent on individual fine aggregates. And so what that resulted in is you no longer have this dilution effect between different amounts of material. And so we've seen some materials fail. A really good example of this, there's a really good Class A material here in Central Texas that we were not able to use because it failed to sand equivalent, which is an indication meaning that it's dirty. However, when we ran methylene blue, it came out to a methylene blue value of 2, which would mean the fine aggregate or the fine particles that cause it to fail sand equivalent were in fact not reactive, meaning they're not clay. And so we still feel this is a benefit to use this material. So really the distinctions between sand equivalent and methylene blue are that sand equivalent will give you a relative idea of how dirty the material is. The methylene blue will give you an idea of if that material is reactive. And so this is really just a second chance to use a material that maybe otherwise you could not use. I'd also like to point out we are updating TxDOT 252, which is the methylene blue test, to be very straightforward, where we would run it directly at 10 milligrams per gram. And you're either going to see the halo or you're not going to see the halo, meaning you can either use the material or you don't use the material. I'd also like to point out lime and liquid anti-strip agent. You'll notice historically with the red language here, it says if stripping is observed during testing or during production, the engineer may require the addition of lime or liquid anti-strip. This is really important because we have changed it to now say you have to put this on the plans. This was a comment from industry that if they're operating in, say, Dallas and in Fort Worth may require the addition of lime, whereas Dallas may not. And so from an industry perspective, this is an incurred cost. This is potentially 2 different designs, and they really wanted to know this up front so they can account for that within their bid. And so if you're in a district that routinely sees stripping, or you like the requirement of requiring lime, put that on your plans up front so the industry knows how to bid for the project. And that way you ensure you also get the lime or liquidating strip. If you don't pay attention to any other slides, I would say this slide and the next slide are probably the most important. It doesn't look like a lot of changes, but I'll explain why this change is going to be very impactful if you're not paying attention. So this will apply to item 341, 344, and 346. It says surface, intermediate, and base mixes referenced in Table 4 and 5 are defined as follows. That was the existing language. We have added unless otherwise shown on the plans. The reason we've done this is we have changed the surface definition, which will impact your recycled amounts and your binder grade substitution. So you can write on the plans to define surface, intermediate, and base differently than what you see here, or you can write in your general notes exactly, the amount of recycle or no binder grade substitution. That is also allowable. So under surface definition, you'll notice it says the final HMA lift placed at the top of the pavement structure. Historically, it said or placed directly below mixtures produced in accordance with, and that's seal coat, PFC, TOM, and thin bonded. And the original intent with that language was that those four materials are not added for structural, right? They're very, very thin. A few of them are even permeable. So that layer directly below them are still experiencing very high stresses, very high strains. And they also are potentially still interacting with the environment above. So under the current language that we've put in the 2024, is the final lift. So literally the riding structure. And the reason this is important is if you're using a super pave CCAT and you've got a TOM on top, under the old spec, you were still considered a surface mix with that super pave CCAT. Under the new specification, that super pave CCAT will now be considered intermediate because it is not the physical riding structure. And so the implications here is if you look at table 4, this is for item 341 because we have some other changes to talk about. But under item 341, if you were a surface mix, historically, that super pave CCAT with a TOM on top is still considered surface. Therefore, you would be allowed 15% fractionated wrap. Under the new specification, right, you are now considered an intermediate because you're not the physical riding surface, which means you would go from 15%. And in terms of item 341, that's actually going to increase all the way up to 30%. So you're going to double the amount of allowable wrap within your material just based on that definition. The other implication is, we said no polymer binder grade dumps, which would mean a 76 can go to a 7022 because they both still have polymer. However, if you specify a 7022 in the surface, you could not dump to a 6422 in the surface because it does not have polymer. And so what you'll see now is that super paved CCAT or that dense graded CCAT we previously talked about. If you specified a 7022 and it's got a TOM on top, you will be getting a 6422 because it's just the most cost-effective binder for the bidding. So if that's not something you're okay with, once again, you'll need to either write in the definition of surface for your district, or you will need to specify the maximum allowable amount of wrap, and you will need to specify no polymer grade dumping or the binder that you want and say no binder grade dump. With that being said, this is going to apply to item 341, 344, and to a lesser extent, SMA, item 346, because we don't do a lot of subsurface SMAs. Item 341 also has some additional changes. You'll notice we've changed the recycled contents. There is a big push from administration and industry right now to utilize more wrap. That really comes down to A few things: the transportation with aggregates across the state is getting more difficult, and the surplus of wrap that we have that are taking up yard space. So we do need to try to use these when available. However, if you're in a district that has issues with high wrap contents within the surface, for example, maybe it doesn't belong in the surface. Maybe it would be better seen in the intermediate. But you will notice that they've all gone up 5%. So also be very aware of that there will be implications if you do not write this into general notes, or if you don't take precaution when putting together plan sets. So 5% increase, and then a 5% increase on the recycle binder ratio. Item 341 and 347, we put this in here just to be very transparent so everybody is aware. The TGC has effectively been removed from the 2024 specifications. So if your item 347 is probably a bigger issue than the dense graded, I believe most districts had already switched over to the SGC. But no, there is no note in there anymore that allows you to pick the TGC as a compactor. For item 347, prior to making this change, I did meet with the level 2 committee. That's all of the level 2 designers throughout the state. And I got them to run their current TOM mix designs that were designed on TGCs and run them on the SGC and make sure that it was doable. And we did not have any issues. So I don't think there will be any problems. If you haven't done it, you may have to do some tweaking with your design slightly, but we have validated that this procedure should work for the designing of item 347. I'll point out, I did say TGC is no longer allowed. Keep in mind that it is still in item 334 and item 330, which is hot mix cold laid and LRA, and it's also in our patching mix. We recently had some research through TTI where we've designed the hot mix cold laid on the super pave, and we've used the ideal RT instead of the Veeam stabilometer. We're now trying to incorporate that into LRA and patching mix while we're also validating the hot mix cold laid. So we hope to have a special spec sometime within the next few years for hot mix cold laid and LRA, and then switch all of our patching mix over so we can effectively get rid of the TGC 100%. So item 342, 344, 346, 347, and 348. Just to do all of the similar ones first, we have removed PFC crumb rubber, we've removed SMARC, and we've removed the thin bonded PFC. We really did that because I queried the usage of those materials over the past 10 years, and those combined had a combined of 5 projects. So not being used, we decided let's simplify the specification. Let's remove the option, and let's just simplify and thin out our spec book. We have kept SMARF. So if you're a user, Odessa, I know, uses a lot of SMARF. We have kept that. Item 344, we've removed the restricted zone or reference zone. Historically, when super pave design method first came about, the concept was if you went through this area, you would create a tender material that would be have a tendency to push during the compaction phase. Under our current 340 or our current 3077, you'll note that we have a restriction on the number 8 sieve, which forces you into a particular curve, shape of a curve on the gradation. And so if you do that, we've noticed that if you go above, below, or through the restricted zone, there's really not an issue anymore because we have already built in some structure just based on the gradation limits. So we've removed this. It's caused confusion in the past as to, is it restricted? Is it reference? What does this really mean? So we have removed that. Exempt production for 342, 347, and 348, we've removed that under the 2014 specifications. There was no exempt production. In dealing with industry for the current special specs, they had requested to add it just for uniformity across our specifications. However, looking at this further, we noticed that there's already no placement testing for any of these materials. You're already getting a 1 or a 0. There are no pay factors associated. So really, what is the exempt production doing for you since you already have limited testing and you only get a 1 or a 0? Item 346 and 347. The black language has already been here. That is the language stating that you can use a Hamburg wheel on the department's MPL. The yellow is just to point out that we're going to create an MPL for the overlay test. Historically, TxDOT MTD was the only laboratory that could run this test. We are going to create an MPL similar to the Hamburg wheel test in which other people can run it as well. I know we have about 10 machines, 2 others being TxDOT districts. So we hope to get this done. We'll create a proficiency very similar, and then we will create an MPL that you can choose from similar to the Hamburg. Item 341 and 344, I'd like to point out the Note 1 modification. Here it says the Hamburg wheel test will have a minimum rut depth of passes less than 3 millimeters. The engineer may require the contractor to lower. That was the historical language. We have changed that to just say the minimum rut depth will be 2.5 millimeters. This was a request by industry. So once again, if a contractor is producing material for both the Austin district and the San Antonio district may require the contractor to do something about that 3 millimeters, whereas the Austin district may not. And so once again, the contractor is going in somewhat blind as to what will the district work require me to do. And you'll note that it used to say we'll lower the design SGC to 35 gyrations. And so the issue there is, yes, when you lower to 35 gyrations, you're increasing the virgin binder content because you're adding less compactive effort. Therefore, you would increase the minimum rut depth. Well, you know, that additional 0.2 of binder is also a cost incurrence to the contractor. So we have removed it and just said that you will have a minimum rut depth of 2.5 millimeters. However, we're not going to specify how they will fix that. And so if that means gyrations, that's one option. Adding some binder could be another option. Adjusting the gradation could be another option. So they do have additional options to get to that minimum rut depth without us specifying. Item 341, 342, 344, 46, 47, and 48. This has been a conversation for at least the past 10 years. When does 10 days start? And so we've always kind of avoided this just because it's difficult to not put stipulations on somebody and maybe some stipulations that are very, very difficult to achieve. And so we have now specified that the engineer will be allowed 10 working days upon receiving the sample from the contractor. So the key here is, you know, historically, the district would get the sample from the contractor. The district says, well, I've got 10 days to do it. Maybe they need to ship it to MTD. MTD gets it, and we say, well, we've got 10 days to do it. So from the contractor's perspective, this may have taken 20 days. And that's not really what the intent was. The intent is to get it done as quick as possible. However, giving 10 days does give you the additional time in case you need it. The overlay, for example, will take 5 to 7 days if everything goes perfect. So if you're in the district and you need MTD to provide some level of testing, overlay, for example, the second you get it from the contractor, you need to ship it over to MTD. That way, when we get it, due to shipping delays, whatever, you know, type of delays are built in, it'll take us 5 to 7 days. So we'll already, if everything goes perfect, we'll already be pushing that limit to 10 total days to the contractor. So please don't let it sit in your warehouse. If you're shipping to MTD, if you're in the area office and providing it to the district lab, please get it to your district lab very quickly because this is something that we would like to try to adhere to, is the 10 working days. Ignition oven correction factors are no longer require a level 2 technician to develop these. You know, this was put into effect that a level 2 needed to do this back when everything was hand calculated. If you look in the past at least 10 years, the way it's been built is the level 2 probably just inputs the data into the TX236 template. The 1A was able to do the wash gradation. They were able to do the ignition oven burn. And so they would then provide that data to the level 2. The level 2 would literally just key it into the template, and the template would output a result. So we have removed this as a level 2 test and added it to 1A. And so the key here is we will go from about 300 level 2s in the state to about 1,100 1A. So this should help. With that being said, this next portion will also not help. And so, but it is something that we got from an FHWA stewardship review, and that is that TxDOT must witness the mixing and batching of correction factors. So we must witness, or we must mix our own for our own correction factors. And so to do this, we're going to add a new test procedure called TX236 Part 3. It's going to be witnessing the mixing and batching of correction factors. That will be a certification level offered through 1A. And we will also certify that through an MTD standalone certification through our class marker program. And once again, this was an FHWA stewardship review. There are no options to not perform this. This is something that we need to do for federal compliance. We did try to break this down to be a little easier to read. So the contractor knows their job duties and the engineer knows their job duties. So for the contractor, we say notify the engineer prior to performing TX236 Part 2, which is the correction factors. Allow the engineer to witness the mixing of ignition oven correction factor samples. Now, if you're the contractor, I would say, have a plan up front. If this means rain days, or, hey, 3 months out, I plan on doing this because, we do these every 12 months. They need to communicate that with TxDOT. And from TxDOT, you need to be on notice that if there's a rain event or something, when they said that they would run those correction factors, I would try to get out there to do that. If you cannot do that, you'll have to mix your own. So it says, if the engineer witnesses the mixing of the ignition oven correction factors, provide the engineer with identically prepared samples of the mixtures. It did say split, and there is a distinction here that I'd like to point out. So split means I'm going to batch up 4,000 grams. I'm going to mix the whole thing with 5% asphalt, and then I'm going to give 2,000 to TxDOT, and I'm going to give 2,000 to the contractor. The problem here is if you get into particular mixes, such as, say, SMA, one person is getting a coarser SMA and somebody's getting a finer SMA. And so inherently, somebody's going to have more binder and somebody's going to have less binder. So when we're trying to compare our ignition oven correction factors, one person is going to have a 3/10 correction factor, whereas the other person may have a 0 correction factor. And then you're going to wonder who's right and why are we different? To avoid this, or to minimize that effect, the idea here is you would do identically prepared specimens. So 2,000 gram batch, put my 6% asphalt in there, I mix it up, and then I pour that out into a bowl, and I scrape all of the asphalt out. That's the contractor specimen. Then they'll throw in another 2,000 gram batch, put the same 6% binder, mix it, and then scrape out all of it and all of the extra binder as well, and put that into a separate bowl, and that would be the engineer specimen. In that scenario, we added 6%, and we should be getting 6% or very close to out of that bowl prior to the burn. So when we get the correction factors, it will strictly be based on the oven and not that the material was different based on segregation. Ignition oven correction factors. So the engineer can determine correction factors by one of the following ways. Witness. We just mentioned that. You would witness the mixing by the contractor and then take your sample back to your lab and run those correction factors on your own ignition oven. The other option is if the engineer does not witness or cannot witness, that the engineer will prepare the samples themselves, and that means batching and mixing. So in order to do batching and mixing, you still must be level 2. So if you need to do that, you'll have to have a level 2 within your laboratory that can mix and batch, and then the level 1A can then run the ignition oven correction factors and the wash gradation on your own setup within your laboratory. Industry did ask that we allow them to come and watch us run these correction factors if requested. I don't think this is going to be something that happens a lot. This will probably be maybe the first few times to make sure everybody knows what they're doing. Everybody's doing it the same way. And after that, I wouldn't expect to see that happen a lot. Approval of Lot 1 production. This note that we added says current JMF changes that exceed the operational tolerances may require a new lab mix design, trial batch, or both. And so I think the key here is JMF changes, right? This is not saying that if you are operating and you have a 3/10 tolerance on the asphalt content and you hit 4/10, that this is going to require a new lab mix design. That's not what this is stating. This is stating that if you were doing that and you're consistently getting lower asphalt and your densities are checking out and you're still within the design requirements and you verified all the performance tests and everything looks good, and we say, I don't know why, but I need to back out or add asphalt or an aggregate sieve outside of the tolerances that are allowed within Table 9, and you're going to enact a JMF change, meaning I'm adopting a new plant design, that may require a new lab mix design, a trial batch, or both. And I think that's going to come down to engineering judgment. If this is, you know, a 3/8 sieve, maybe that JMF change is warranted, but maybe it doesn't really change the overall performance of the material. If that's an asphalt content, maybe that would warrant at least a trial batch and a Hamburg, maybe partial lab mix design. So that'll really come down to engineering judgment at that point. Production operations. We've always had some language that alluded to some of this, but it wasn't very clear. And so we were aware of a few scenarios this last year that were not okay. And so we have put in these two highlighted portions that say all asphalt source changes will require a passing Hamburg result from a laboratory listed on the department's NPL. The key here is if you're doing a project and it's got a PG 7622 and it's failing and you don't know why it's failing, and then you change that PG 7622 to a different source and it's still that same, and still a PG 7622, and all of a sudden it passes. We've seen this time and again during forensics, right? And so what we're saying is the opposite could also be true. So you have an approved design, everything's working, you're using an approved binder, you got passing Hamburg results. All of a sudden the contractor gets a cheaper binder from a different source and they bring in a different source. You could go from a passing Hamburg to a failing Hamburg. We've got the binder sampling program for a reason. Really, it's to document the performance of these binders. And if they start failing, we can link projects together. So this is no different. So if you change sources, just note that you did the source change and then have a passing Hamburg result to associate it, just to make sure that the changing of that binder source is not negatively affecting the performance of your material. On the other hand, here we have all aggregate source changes will require a new lab mix design and trial batch. So the key here is, you know, if an aggregate source change, that means physical aggregate quarry, you know, I'm getting material out of a different location. We just talked about the importance of the correction factors. So if you change the aggregate source, you've changed the absorption, you've changed the volumetrics of the material, you've changed the correction factors, you've probably changed the gradation because you're not going to be able to match it perfectly. So you've essentially created an entirely new mix. So if aggregate source changes happen, you're going to need to go back through a new lab mix design and trial batch. Now, if you've got a 100,000 ton project and the contractor only has 50,000 tons of the first source stockpiled and he knows he's going to run out, what I would say is go ahead, identify that second source, and do the trial batch up front. Do the lab mix design up front. And that way it's already approved. Everything's good. You've got essentially 2 approved lab mix designs and 2 trial batches at the beginning of the project. During the project, you get to that 50,000 ton, you run out of the first source, you take a day, switch over to the other one, and keep going. This is something that you should be able to see up front. There's no reason why this should cause delays. but we also don't want to just do aggregate source changes without noting that and verifying that we're still getting the same quality of material, because it will be different. Placement operations. This historically said to take the measurements out of every truck. Our current special specs have so many different locations where we're measuring minimum temperatures, maximum temperatures, before it enters the paver, after the paver. We felt that this is maybe redundant, and so to relieve some of that testing, we now say measure the mixture temperature at a minimum frequency of 1 per 10 trucks, or as approved by the engineer. So beginning of the project, beginning of the day of production, maybe you're going to take the first 5 trucks to make sure you've got consistent temperature. If you're hitting 300 degrees and you check every 10 trucks and it's still maintaining 290 to 300 degrees, you would say, okay, we have very consistent temperatures. We don't need to check more than 1 for 10 trucks. If the target is 300 and they start coming in at 250, 260, as the engineer, I think I would say maybe we need to increase that frequency to ensure we're not getting cold trucks, or let's also ensure we're not getting hot trucks, right? If they start showing up with blue smoke, maybe you would also increase that frequency. Weather conditions. This is pretty confusing within the current special specifications. We were asked originally to reword it, so we were going through to reword it. Upon further discussions with industry, they asked us to just remove it. If you were a district that needed this note in here, I would say put this in as a general note. Call MTD. We'd be more than happy to talk to you about what the intent of this note was and help you to come up with that note. Really, one of the problems with it was the misinterpretation of the language. So is it the ambient temperature is likely to drop below 32F after 12 hours of paving, or is it if it's likely to drop below 32 12 hours before I am paving? And so there were 2 interpretations. One interpretation may help you more. Also, 12 hours may not work for your district, right? Maybe it's 8 hours, maybe it's 4 hours. And so aside from the really cold districts up in the Panhandle, this may not even apply to you. So we were asked simply make this a general note, let the districts that need it, let them specify it accordingly. Compaction, complete all compaction operations with breakdown rollers before the pavement temperature drops below 180 degrees Fahrenheit. Historically, this would have said complete all pavement operations by 160 degrees Fahrenheit. However, it also states that you can open it up to traffic at that point. I'm very, very confident that a contractor can get density down to 160 degrees Fahrenheit with a large enough breakdown roller. That is not the intent. We do not want to just fracture aggregates and fill all of those voids with aggregate dust. That is not the same as quality density, right? We're just trying to say that that when we get density, we want those voids filled with asphalt. We want it to be consolidated material, not crushed material. So we have now specified breakdown rollers will be off the pavement by 180, between 180 and 160. Compaction with the pneumatic or light finish roller operated in static mode will be allowed. So that's really just getting that final riding surface, getting out all of the pavement markings, the roller markings. In item 347, we've added the permeability flow test. Also, this is not an addition. This is something that was already in the test procedure. So text 246, if you read it, it would tell you how to perform this, and it had a specification item within the test procedure that said Tom should go at least 120 seconds or greater, meaning that it's not permeable. Well, that's not really the spot to put it within a test procedure. So we've removed that language from the test procedure and put it into item 347. Once again, this is not a new requirement. It's just being added in the specification where it should have been from the induction of the test. Note 3 was modified here to allow 20 degrees delta instead of 10 degrees. So prior to this, the language would say that you are allowed 10 degree different than this table, right? 10 degrees lower if you were utilizing warm mix asphalt as a compaction aid. Now we have increased that to 20 degrees, and we've also added an MTD with remixing capabilities, and we've also added a paver hopper insert with remixing capabilities. Really, the intent here is we want uniform temperatures throughout the material. So when you start getting colder temperatures, you're going to start finding cold spots within the material itself. Some areas may compact better than others. So a warm mix additive does help with the uniform temperature. It helps with staying workable at lower temperatures as well, so you can still get compaction. These other two are keeping uniform temperature with the remixing. That is the key here, is the remixing. And so keeping uniform temperatures, we will allow 20 degrees lower, knowing that we're not going to have these localized cold spots. Production sampling, the engineer will perform or witness the sampling of production sublots. This is not something that's new. This is something that we just needed to clarify. So when we're doing production sampling, I do realize some contractors will not let TxDOT get in the back of a truck to sample loose material. So in which case the engineer will witness. So either the engineer needs to be on the sampling platform, sampling from the backs of these trucks during production, or they need to witness the contractor doing it. When the contractor does it, or when TxDOT does it, you'll grab enough material to then combine together and do a sample split into 3 equal portions, and that would be for the contractor, the engineer, and for referee. Blind sample, this is also not something that's new. This is something that we added or we clarified based on an FHWA stewardship review. FHWA met with MTD and asked us our interpretation of this part of the specification, and then they asked a number of districts. And unfortunately, they got a bunch of different answers. So we were given 2 options. One is TxDOT goes to 100% blind sampling, meaning the contractor never knows the production location, and TxDOT just goes and samples random trucks. Option 2 was we do it as we are currently doing, in which the contractor can have the production random locations. They call TxDOT and say, this is when we're sampling, meet me out at the sampling location. However, 1 sublot per lot, the engineer would be taking a true blind sample, meaning the engineer does not share that number with the contractor. If the engineer's sampling, they would literally call the contractor and say, I'm sampling this next truck, meet me out there so you can witness me sampling. Or if the contractor is the one sampling, TxDOT would call and say, okay, within the next 2-3 trucks, we'll be sampling, meet me out there. And then in which case TxDOT would witness the contractor sampling on their behalf. And then we would do the same protocol in which we split for contractor, engineer, and referee, noting that any referee test will be based on the blind sample for that given sublot. So if you get a blind sample and a random sample in sublot 3 and it goes to referee, it is based on the blind sample. So if you are the contractor, you do not need to test that random sample for that given sublot. You would be testing the blind sample. Everybody's testing the same material in this case. Hamburg wheel test. Unfortunately, this is something that was brought to us by industry. There were fears that this had been abused throughout the state in particular districts. You've got a 1 minimum production testing Hamburg per project, and you get to the end of the project and realize you didn't ever run your production Hamburg, and you go, uh-oh, what do I do to clear the site manager deficiency? They would go take a core and run Hamburg, and that would suffice as the test. That's not really the intent of this. This was really more of a forensic in which we've already got failing Hamburg productions. Maybe we noticed some issues on the roadway, some failing rutting on the roadway. And so we would take cores and run the Hamburg wheel test on that as well to determine the severity of the rutting. Due to this being misused, we have removed this from the specification. So Hamburg will be based on plant-produced mix, so loose mix. If you're the district, what I would say is take additional material at the time of production sampling if you know you're going to run a Hamburg. Otherwise, the Hamburg would be run on referee on a referee bag. The problem with that is if you need that referee bag for another reason, such as a density referee, you won't have that material to reference back to. And then the yellow portion down here has always been assumed, but we have heard of other labs or district labs trying to act as the referee testing laboratory. That's really not the intent. The intent is it's a completely non-biased third party within TxDOT. So we have specified very clearly here that Materials and Test Division will be the only referee laboratory for retesting failing material. Miscellaneous areas. This is another one of those, I would say, kind of larger changes. If you're not paying attention, it could be confusing. So under item 351, which is flexible pavement repair, it points to, or it historically pointed to item 340, which was our small quantity hot mix specification. And so you would go to item 340 and then produce and lay material in accordance with item 340. Past few years, we did discontinue item 340. And so now if you read item 351, which is the flexible pavement repair, it'll point you to exempt production within item 341 or 344. The problem is when you get pointed to exempt production, there is a higher level of testing associated with exempt production. So to remedy this, we have added some language both under the miscellaneous section within the specifications and the exempt production. And so what this does, now we say if the pavement repair section is under 300 linear feet, what you will do is it'll point you back to miscellaneous within the specification. And so miscellaneous have limited testing, and they have a 1.0 or a 0 type pay scale with very limited testing. The idea there is, you know, if this pavement repair section is 20 foot, is that really fair to call that exempt production when you can't really even get a paver on it to get consistent placement? So if it's over 300 linear feet or over 300 feet, what we say is it is going to be exempt production because there's no reason you can't get a paver on it and just pave it as you normally would. And so we felt that this was fair. So keep an eye on that. If you have any questions, feel free to reach out to us. 342, 347, and 348. So TOM and PFC specifications now state miscellaneous areas are not subject to thermal profiles or water flow testing. As I mentioned originally, you know, we don't do, for miscellaneous, we don't do roadway cores for our normal specifications. And so the water flow testing is somewhat the replacement for in-place air void testing for those three mixes. So if we're not doing air void testing on our 341, 344, and 346, why are we essentially doing the same for these other when they're placed in miscellaneous? Shear bond informational testing. The idea here is we would like to build a database to know what materials, what combinations, what thresholds really are giving us the best bonding. So we originally wanted to have this as a specification item. Industry did ask that we just make this informational. What I would say is don't make this informational at the end of the project. Don't get to lot 100 and say, oh, now let's run that shear test, and then you determine that it has bad bonding. Use this within the first few lots. Even though it's informational, use it as a tool. If it's getting below 40 PSI on the bonding, you probably need to do something in terms of surface prep, maybe better tack application, a handful of different things, maybe cleanliness. So definitely do this up front to set yourself up for success later on in the project. Segregation density profile, nothing has actually changed here. I only put it here because there has been some misinterpretation of what this table means. So table 17 here, the segregation density profile only applies if you are not using the paver mounted thermal imaging system. If you're using a handheld, this applies to you. If you're using the paver system, this does not even apply. So when using the handheld, we also wanted to clarify the reasons when you would run a segregation density profile. So one is areas that are identified by the contractor or engineer with severe thermal segregation. That's currently in the specification. Any visibly segregated areas, also currently in the specification. And then we clarified this last bullet where it says the paver stops due to lack of material being delivered to the paving operation and the temperature of the uncompacted mat before initial breakdown rolling is less than the temperatures in table 17. So the distinction here being that is that we're trying to prevent a paver stopping because maybe there's a trucking delay or something like that. So they have no material coming in. They've stopped the paver, and the roller operator is 100 yards back and not able to get compaction up to the paver because the paver has not moved, right? There's not adequate room. Maybe the paver operator is having breakfast, smoking a cigarette. And so really the intent here is that we don't want that material directly behind the paver that has seen zero breakdown rolling. We don't want it to drop to a threshold to where we're no longer going to be able to get density. Exempt production. At the very top here, you'll see where it says when mutually agreed between the engineer and the contractor or when shown on the plans. We added that, and the distinction here, the mutually agreed upon, there was some abuse throughout the state. We set up a 1,000 ton lot. We hit the 1,000 ton by 11 o'clock in the morning. So what do? Should we open up another lot? Or maybe we just opened exempt. And so what was happening is that was happening on a daily basis, and they had over 100 lots of exempt production, and that wasn't really the intent of this, right? What could they have done better? Well, the next day you could have communicated and said, maybe we just need to open a 2,000 ton lot, and we either get 2,000 tons, or maybe we only finish at 1,700 and you close the lot out. That probably would have been a better solution. For that one day, would it have made sense to say, yeah, let's do exempt production just today, and then tomorrow we'll establish a better lot size? Yeah, maybe that would have been okay. But that's where that mutually agreed upon between the contractor and engineer, because what ended up happening with that project that had over 100 tons of exempt production was the contractor essentially lost out on all of the bonus opportunity. We've also added pavement repair sections equal or greater than 300 feet. I've recently talked about this in miscellaneous. So under 300 feet, it's still miscellaneous. Greater than 300 feet, it'll be exempt. And this is in reference to flexible pavement repair, which is item 351. While this is not new, it wasn't ever actually explicitly stated, exempt production is not eligible for referee testing. We now have it in the specification, so it is very clear. And then finally, we added when mutually agreed between the engineer and the contractor, production sampling will be allowed at the point of delivery. This may not help your big metros, but this will definitely help out your rural districts. So if I have a project and it's 100 miles from the plant and it's exempt production, and I'm only doing 200 tons on this small project, does that mean I need to have a 1A at the plant? And then I also need to send this 1B 100 miles away to this location, right, to where they're doing the roadway testing. So what we're saying here is, can we just sample from the windrow at the project, for example? The QA material is brought out there, it's dropped. The 1A, the 1A, 1B is out there, and they sample the material directly from the windrow. They take that as the production sample, and then the 1B is actually out there to take the placement sample as well. And with that, that's all that we have. Here's the contacts for the flexible pavement section. So please feel free to reach out to myself or anyone else. I've also included the TxAPA contacts. Utilize them as a resource. We're all here for both TxDOT and for contractors. So if you have any questions, feel free to reach out.